Geometric Series, section 10.5. So if you've got your notes, we're looking at section 10.4 today. And then tomorrow will be section 10.5. Now, if you'll notice, I didn't just do the teal problems on here. I kind of added some other stuff in, skipped around. So we're going to be skipping around, so you're going to have to kind of pay attention to the problem number list that I have up here.
Okay.
All right. Okay, we're going to do number 1, 2, and 3, then number 9, number 10, number 12, 15, 19, 23, 24, 28, and 29. Yeah. There's problem numbers that are up there that I don't have on the board. So there are going to be a couple of them that I'm going to ask you to do on your own, like I normally do. Okay. You'll notice, if you can see right behind me, I've got 1 and 2, and then I skipped to 9. That means number 3, you're going to have to try to do on your own. Okay. And then 10 and 12, you're going to have to do number 10 on your own. I've got 12. You're going to have to do 15 on your own. I got 16 and 19. And I got 23, 24, and 29 down there. So there are about 4 problems that you're going to have to try to do on your own. Okay? So we've got everybody except Nelly and Andre, so we can get started. Oh. Somebody slammed the door. All right. So what we are talking about, if you look at your notes paper, if you have your notes where you can actually print them out, or you can just flip back over in the book at the section. For a geometric sequence, instead of adding the same number every time like we did in the arithmetic sequence, we are multiplying by the same number every time in the geometric. So instead of having a common difference, they have what we call a common ratio. That's the constant term, the number that they multiply every single time to get the next one in the sequence. Okay? So the first problems, that's what we're going to be doing. It asks us to find the next term in the geometric sequence. So to be able to find the next term in the geometric sequence, to be able to find the next term in the geometric sequence, what we're going to do, oh, she decided to come. All right, is we're going to first have to find that common ratio. So we're on page 472 and 473, Yaneli, section 10.4. To find a common ratio, it's similar to what we did for the common difference. Common difference, we took second term minus first term. So common ratio, you're going to take second term divided by first term. Because it's something you're multiplying by, so the opposite of multiplication is division. We'll divide to find what it is. So we're going to take our second term divided by the first term. So our second term in the sequence of number 1 was 26. Our first term in the sequence of number 21 was 13. So 26 divided by 13 is just 2. So my common ratio is 2. So the number that they keep multiplying by to get the next term in the geometric sequence is 2. 13 times 2 was 26. 26 times 2 was 52. 52 times 2 was 104. 104 times 2 will be 208. 208. So the next term in the sequence is 208. Okay. So these first 3 problems should be fairly easy. You first find your common ratio, then you multiply it by the last term that it gave you to find the next term in the geometric sequence. So we're going to do the same concept on number 2. Find the common ratio. We take second term, 52, divided by first term, 13. So 52 divided by 13.
4.
4. 4. So my common ratio is 4. So I'm going to take my last term here, and you all probably can't see it because the glare on the board, but you got it in your book, is 832. So I'm going to take 832 times 4. So if you'll notice with the geometric sequences, are we going to have really large numbers?
Yes.
Yeah.
More than likely, you're going to get a lot larger numbers in these because you're multiplying to keep getting the next term. In the arithmetic ones, we were adding, so they didn't get as large as quickly. But when you're multiplying, they're going to grow larger faster. So I've got 832 times 4.
3,328.
Okay, I just heard like,
8,328.
all right.
Or 3,328.
All right. I heard 3 and then I heard the 8 and then I was like at the end and I was like, whoa. All right, so it's 3,000.
Ugh.
What?
Sorry.
In a moment. Are you okay?
Yeah, I'm good.
Okay, good. All right, so on number 3, are we going to do the same concept? Yes or no?
No. Yes.
Now, number 3, you're doing number 3. So what I want you to do on number 3 is take your second term in the sequence, and divide it by the first term. And the thing is, this time you're going to end up with a fraction when you divide that. When you do your second term divided by your first term, you're going to have a fraction. Okay, I'll squeeze it in right here. Because what's my second term in the sequence?
64.
64. So I'm taking 64 and I'm dividing it by 256.
Uh-huh.
Now, the same thing as dividing it is I can just reduce it. If I don't have my calculator, I can reduce it by taking common factors out of each one and simplifying. Okay. So I know 8 goes into both of them. 64 divided by 8 is 8. 256 divided by 8.
Oh.
332. So then I have 8 over 32. Can I still simplify that?
Mm-hmm.
Yep. 8 goes into 8 one time. 8 goes into 32.
4 times.
You get 1/4. So now you're going to take 1/4 times the last term. What was the last term they gave you in the sequence?
4.
So if I take 4 times 1/4, what's going to happen to the 4s?
Cancel.
You'll cancel. So the term of the sequence is
1.
1.
How many of you were at least on the right track with that, even though you had the fraction you had to reduce? That wasn't very nice of me to give you that one to try. I'm sorry. I should have let you try number 2 on your own, but oh well. It's okay. We did it together anyway. All right. So after 1, 2, and 3, the next one was number 9, 10, 12, that next section. So on our directions for that section, it says find the formula for the nth term in each geometric sequence, and then use this formula to find the indicated term of the sequence. Now, on your notes or in your book, you have a formula for the term. I'm going to put my formula, my basic formula right here. You've got it on notes or in your book, but I'm going to write it here so you're not looking back for it. A to the n is equal to the first term times r to the n minus 1. Now remember, a with a little subscript of 1 just means your first term. A with a little subscript of n means the nth term, whatever term we're looking for. So 6th term, my n would be 6. Okay, so that's what we're doing. That's what we're plugging in. So we're going to take this and write the formula for that and find it. Okay, so like I said, on number 9, it says 6th term of 2, 14, 19, blah, blah, blah. Okay, so I start off with n is equal to 6. That's my nth term, right? 2 is my A1, my first term in my sequence. What else do I have to find to go into this formula?
The ratio.
The R, right? The common ratio. How do we find the R?
14
Divided by
2.
You take second term divided by first term. So 14 divided by 2 is 7.
7.
So to be able to plug them into the formula, you have to know N, you have to know A1, and you have to know your R. Okay, so now I'm ready to plug them into this formula and then simplify it. So I have my sixth term is equal to A1, which was 2. Two things right next to each other in algebra means multiplication. So that's times R, which we found was
7.
7 to the N minus 1 power. N was
6.
6 minus 1 up here. So we got to simplify that now to get our answer. Okay, so first step is you got to simplify the exponent before I can take it to the exponent. So 6 minus
Let's go. Shut up.
mute yourself if they're all. So 6 minus 1 is what?
5.
5. Okay. So can I do 2 times 7 first, or do I have to do 7 to the 5th power first?
7 to the 5th.
7 to the 5th power first, okay? So when I'm doing 7 to the 5th power, that means 7 times 7 times 7 times 7 times 7, or you have a little calculator and you put in 7 with a little exponent of 5. Are we going to get a big number?
Yeah.
Yeah, we're going to get
16,807.
I'm cheating today. I went and got the calculator.
16,807. That's what I got.
So I have 2 times 16,807. Okay. So then my 6th term is going to be 2 times that. So it's going to be
33,614.
Okay. So if you have a calculator on something that you can use, phone, tablet, whatever. I mean, it doesn't have to be a scientific calculator. Because 7 to the 5th power, you could type 7 times 7 times 7 times 7 times 7. You just got to count, make sure you do the right number of 7s. So whatever kind of calculator you can find is going to be helpful in these. Okay, so that was number 9. So we're using this formula right here. We're going to use this formula over and over again for the rest of these problems till the last little part. So we're using this formula here. We got to label what we were given in the problem, plug it into the formula, and then simplify it. So that's the same thing that we're doing up here on number 12. Okay, so I skipped number 10, so that's one you're going to come back to in a few minutes and do yourself. Okay, but on number 12, we're looking for the 9th term of -6, -12, -24, -48, and so on. So my first step is to identify what I have. What is my N in the problem for number 12? What term are we looking for?
9.
9th term. So my N is 9. Okay. My A1, what's my first term in the sequence?
-6.
-6. And then I still have to find my R. To find my R, remember we take second term divided by first term. So -12 divided by -6. Negative divided by negative makes it
Positive.
positive. So divided by 6 is 2. So we've got our numbers. Is everybody done with 1, 2, and 9? I want to go scoot over till I give people a chance to kind of get those down first. Okay. So after you have them identified, we're plugging into our formula right here. Okay. So I'm looking for my 9th term, and that's equal to my first term, which was -6, times my r, which was 2, raised to the n minus 1 power. So n was 9, 9 minus 1 power. We simplify, we're ready to solve. So 9 minus 1 first is 8. And then we have to do our multiplication. So I've got 2 to the 8th power.
Okay.
2 to the 8th power means you're multiplying 8 by itself, 2 by itself 8 times.
256.
56. And then now I multiply that by -6 because that was my first term. And so we get what for our answer?
Negative 1,536.
All right, do y'all agree with him?
Mm-hmm.
You've been trying because you don't have a calculator?
I don't agree.
Who doesn't agree?
I don't.
You don't agree with yourself? What did you say? Who's saying that? All right.
Micah.
You talking about Marquise?
Oh. Well, he keeps hiding, so I can't do anything with him. I can't even see him half the time. He keeps ducking down.
Because I'm looking at my paper.
Uh-huh.
I'm taking notes.
Yeah. All right. So everybody's got number 1, number 2, and number 9 down, right?
Yes, ma'am.
Number 3. Yep. Okay. I'm scooting just a little bit. So we've done number 9, and then we skipped number 10 and went to number 12. We're skipping number 15 and going to 16 and 19. I'm doing 16 and 19 with you. I picked them. Number 16 is fairly large numbers. That's why I picked to do that one with you, because it's a little bit harder because it's bigger numbers. Number 19, I picked to do that one with you because it's what they call an alternating sequence. If you look at the problem for number 19, it alternates or goes back and forth between negative and positive numbers for the terms. That means our common ratio is going to be a negative, because a negative times a negative makes it positive. A positive times a negative makes it negative. Negative times negative makes it positive. So it keeps alternating between a negative and positive because the common ratio is negative. So I picked these two to do with you, and then number 10 and 15 are simpler, so you'll go back and try those. Okay, so for number 16, we're looking for the 6th term. So my n is equal to 6. Whatever term you're looking for is your n value. Okay, so that's my n value. And then my A1, my first term, is the 16. And then I have to still find my common ratio. So to find my common ratio, remember you take the second term divided by the first term. So I'm taking 128 divided by 16. Anybody?
8.
8.
8.
Okay. Okay. So we got our N, we got our A1, we got our R, we plug them into our formula. Okay, so my 6th term is equal to A1, 16, times R, 8, to the N minus 1. N was 6, 6 minus 1. So to simplify, we simplify this right here first. 6 minus 1 is 5. So I will take 16 times whatever 8 to the 5th power is. So you got to do 8 to the 5th power. You get a big number.
32,768.
Yeah.
And then you whoops, I hit the wrong button. Then you multiply that by 16.
That is 524,288.
Okay. And that's why I went ahead and did that one, because we have a larger number. Okay, but you shouldn't be surprised we had a larger number, because the first term was a bigger number, 16, and then my common ratio was a larger number that was being raised to the power. Okay, because others, we had a little bit smaller number to raise to the power. Now, remember on 19, we're still doing it the same way. The only difference on number 19 is it's an alternating sequence. So everybody understand alternating? Hint, quiz question tomorrow, I think. No, not tomorrow, Thursday. Whenever I told you, your quiz, whenever it is, later this week. That's when the questions, it's what type of sequence when it goes between negative and positive. Alternating, okay? So my n is going to be 7th term, so my n is 7. My first term is
6. -6.
6. And then my common ratio, you take second divided by the first.
First.
6 divided by -6. Now remember what I said earlier when I first started talking about alternating, your common ratio is going to be a negative number, because a positive divided by a negative is negative. So 66 divided by 6 is 11. So it's going to be -11 is my common
Negative 11. Yeah.
So now we're ready to plug into our formula. So I'm looking for my 7th term, which is equal to my first term times my common ratio raised to the n minus 1 power, 7 minus 1 power. So 7 minus 1 is 6. Now here's where you have to be careful. If you are using a calculator, you have to be careful when you're putting a negative number raised to the power, okay? Because a lot of calculators, if you don't put parentheses around it, like -11 to the 6th power, it's not going to take the negative, and it's still going to leave your answer as negative. But if I've got an even number of negative factors, my answer is supposed to be positive.
Positive.
So just be careful with that negative on there. Or you can just leave it off if you know you're going to an even. But 11 to the 6th power gives you a huge number.
1,771,561.
A huge number. And then we're multiplying that by the -6. Because our next term we know has to be negative because it goes in order. Negative, positive, negative, positive. So my 7th term's got to end up being negative, okay, because it keeps alternating. The odd number terms were negative, the even number terms were positive. So we're taking that answer times -6, get negative 106.
Negative 10 million.
Yeah, negative 10 million.
629,366.
What he said.
Yeah.
So you get big number. Okay, so like I said, I tried to skip and do ones I knew were a little bit harder, a little bit larger numbers with you. So I left you to do number 3, which we already did that one together. So the only 2 you still have to do on that part is number 10 and number 15. So take a minute or 2 and try to do number 10 and number 15. Okay. Y'all have any luck?
Almost.
I'm done.
Okay, now I didn't put the entire thing up here as far as all the work, but we're going to go through, and if you got your N, A1, and R labeled correctly, then hopefully you were able to plug them into the formula and get the right term that it was asking for correctly. So on number 10, it was asking for the 8th term, right?
Mm-hmm.
The 8th term. So on number 10, N was equal to
8.
8. The first term that was given to you already in the sequence was
11.
11. When you find your common ratio, you took second term divided by
Oh, I can't even see that.
I don't know what he said.
You take second term divided by first term and get
The third term.
Are we on number 10?
Ratio.
yes,
Yeah,
we're on number
100%.
10.
You get the ratio thingy.
Yes, the
That would
common
be
ratio.
3.
What?
That would be
3.
3.
Yeah, 3.
Yeah, 3.
You have 3 divided by 11, so you get 3. And so you plug all those in, you work it all out, and you got the 8th term. Who thinks they have the right answer?
Not me,
Hey.
Miss Plum.
Oh, no, wait, no, I don't. Oh, yes, I do. Hold up.
I didn't get that. I didn't get that. Hold on.
I got 24,057.
Big number.
Big brain.
Now, there should still be work there, so if you just write that part down, not gonna cut it. Okay. I'm gonna ask you to show me. All right, number 15, same concept. Number 15, what term were you looking for?
The 7th term.
The 7th term, so N is equal to 7. The first term that was given to you in the sequence?
Plus 24.
24, is that right?
Yeah.
Just trying to make sure I'm looking at the right problem. Okay, your common ratio, if I take second term divided by the first term, my common ratio was
3.
3. And then I plug these in. I'm going to have a big number again because I've got something that's going to be multiplied by 24. But what do you get for number 15 for those who did it?
I got 17,496.
17,496?
Yeah. Yeah. Is that wrong?
Because all I heard at first was like something thousand. I didn't hear the 17. Okay.
Alright.
So if you plug these things, the first 3 things in, and you can't get the answer that we just said up here, then at the end of class, you need to stay on here and ask me so we can figure out what you did wrong. Okay? Because remember I said what's coming up soon? Another quiz. So you need to be able to do that. Okay?
Okay.
So number 10, 15, you got them right here, the basics, but you have to have the work where you figured the rest of it out.
Y'all.
All right?
Okay, so it's like last quiz, so we have to like fill in like the blanks. Or like
What?
you know how
He
last
said,
thing
is it like the last quiz we gotta fill in the blanks?
yeah.
Yeah, some are just fill in the blank. There's a couple that are gonna be these that we're getting ready to talk about here. They're just a little drop down box. You just pick the right one. Okay. And because what we're gonna be talking about, and then there's a couple that were like most of it's like fill in the blank, I think. And then you've got the drop down ones, which I'm getting ready to talk about those. With
Okay.
these last sections, okay, it's talking about the geometric series can converge. Converging means it's coming toward one single number.
Uh-huh.
Or it can diverge, which means it's going
Opposite.
out away
Opposite.
from it and it's getting farther and farther away. Okay?
Oh.
So converge is coming together into one single number. Diverge is going away.
Spreading apart.
Away.
Okay? So
Yeah.
we have rules on our notes about converging and diverging. Okay? If the R absolute value, remember that's what those little bars mean. If the absolute value of R is less than 1, that means it's coming together, it will converge. If the absolute value of R is greater than 1, that means multiplying by a big number, it's going to keep getting huge and huge and get bigger and bigger. So like these, they kept getting bigger and bigger. It's going to keep going. We had the 524,288 on number 16. You kept multiplying by a big number 8 every time, so it's going to keep getting bigger and bigger because R was bigger than 1.
So it's converged and
19.
submerged.
R was negative 11. Is it still going to keep the diverging?
Diverge. Yes.
10 million something. So it's getting bigger and bigger. It's going out further every time.
Yeah.
Now, on
But
number 3, our common ratio was 1/4.
Yeah.
On number 3, it's going down smaller and smaller, so that's going to converge. So
Yeah.
if R value is less than 1, it's converging. If it's bigger than 1, it is
Divergent.
Divergent.
okay. So
Let's go.
it's going to be a drop-down box. It's going to have like the thing here.
Uh-huh.
And you're going to have to figure out R, which hopefully you know how to figure out R by now. We take second term divided by first term. You're going to find R, and if the absolute value of R is less than 1, you're going to put the little box where it shows converging, and then you're done with that question. If it's bigger than 1, it's going to be diverging, so you will click on the little box and change it to where it says diverging, and then go to the next question.
Okay.
Okay, so you're just going to pick converging or diverging on those. So,
Thumbs up for me.
huh?
I said thumbs up for me.
Okay, good. So, on 23, 24, and 29, I skipped number 28. So, number 28 is one I'm going to have you work on your own in just a minute. We're trying to figure out whether they're converging or diverging.
Divergent.
To be able to do that, we have to figure out R first. Now, what I'm going to do is I'm going to rewrite this where it looks more like our formula that we had. Okay, our formula, remember, was AN was equal to the A1 times R to the N minus 1, right?
Mm-hmm.
That was our formula. Okay, that's our formula. That's not part of the problem necessarily, that's the formula. So what we're going to do is we're going to use that and rewrite our thing. So this is what's raised to the power. The 2 right there, see?
Uh-huh.
This is what's raised to the power. So I'm going to separate it into 1/5. So I'm taking the 2 off separate times 2 to the n. So this is my first term. This is going to be my
Second.
no.
Wait.
The
R.
R.
so my R is equal to 2.
2.
So is that less than 1?
No.
Nope.
So is it converging or diverging?
Divergent.
Divergent.
Right. Diverging. You basically kind of simplify the fraction. You to put it in, oops, sorry. You put it into 1 over whatever the denominator was times the thing that's raised to the n power. And then whatever's raised to the n power is your R. Okay? So we're doing the same thing on 24. Doing the same thing on 24. I'm rewriting it first. So it'll be 1/2 times -4 to the
1/2 times -4 to the n power.
That's my R.
R is -4.
-4. Now remember, when it has it on your notes or in your book and we're talking about it, comparing it to 1, it's always the absolute value bars. So it's the absolute value of -4. So on this one, absolute value of 2 was greater than 1, so it was diverging. On this one, absolute value of -4 is still going to be greater than
1.
1.
2.
Remember, absolute value is how far it is from 0, so it's still positive. So 4 is greater than 1, so it's still going to be
Diverging.
diverging on that one. Okay, so that was number 23 and number 24. So then the next ones that we skipped to were number 28 and 29. I'm doing number 29 because it has fractions, and I know how much you all love fractions. And then you all will try number 28, okay? So when we're trying number 29 here, we're looking for the R, our common ratio. To find that common ratio, you take second term divided by first term. Now I wrote it like this so I didn't have fractions in a fraction because that's even more confusing. Okay, so I wrote it out the old way with the division sign. Now, when we go to divide this, remember to divide fractions, we do copy.
Copy, change, flip.
And then we look for stuff that we can cancel. 6 goes into itself 1 time. 6 goes into 18.
3 times.
3 times.
Multiply straight across.
6 is 18. 1 times 1 is 1. 3.
So my R is
R is 1/3.
absolute value of 1/3 is
It's still 1/3.
so that's less than 1, right?
So that's converging.
Less than 1, we will say it is
Converging.
Converging.
converging. Okay,
Yeah.
easy.
Mm-hmm.
Okay, so do number 28 real quick.
Okay.
Number 29, it gives you the list. You have to find R, compare it, tell me converging or diverging.
We just got a letter. We just got a letter. We just got a letter. I wonder who it's from.
Why are you doing Blue's Clues, please?
Wait, the mic was on? Oh my gosh.
Okay. Alrighty. Lord help us.
Thought the mic was off.
Okay, did anybody figure out what R was on number 28?
Yeah, I did.
Well, good.
Yeah.
Anybody else figure out what R was on number 28?
Nope.
Really?
It's really
I see you trying to hide. What's the R? Unmute yourself. Speak.
Is it 5?
Yes.
Oh, okay.
Because you had 25 divided by 5, so that's 5.
25 divided by 5 is 5. Times 5 is 25. Times 5 is 125.
Is the absolute value of 5 greater than 1 or less than 1?
Greater.
Greater than 1. So is it converging or diverging?
It's diverging.
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 That's what I said.
Mm-hmm.
Let's go.
Okay. So should you have today's work done?
Yes, ma'am.
Yes, ma'am.
If you have your notes.
Yes, ma'am.
Yes. Should you?
Actually, I don't have the notes yet. But
Okay. Just you need to try to probably get them. If you can find a way to print them or whatever before test would be good. Okay. Now,
I mean, I have the notes, I just don't have the correct words written in yet.
well, why not?
Well, see that I didn't think I was gonna be here today. I thought I was gonna go to Fort Myers for separate reasons, but that didn't end up happening. So my mama made me stay home. So
Well, but the thing is, when did I ask you to work on filling in notes?
like
Last week. Marquise, where'd you go hide? You better come
My
back.
phone's
usually work on
going dead.
Okay.
It's at
I
20%.
usually work on them like kind of like before class, but
Yeah, you were supposed to do it last week. But anyway, so before you all get off of here, okay, Yaneli, what time's class supposed to start?
At 1.
At 1. So when we do Zoom, whatever class time it is for everyone, I'm saying this for everyone because she's not the only one, you need to make sure you log in when? On
1
time.
o'clock.
With
On the time.
ready.
on time.
You need to have your camera where I can see you, not your ceiling or
Marquise,
walk behind you and like one little
I'm in the camera.
hair sticking out so I know that you are there. Okay, I need to see more than that. Okay, because this is your grade right now, is you being logged in and participating and doing that. So if I can't see you and see that you're following along, then you're not participating, you're not getting those points. Or if you come in late, you're missing, so you're not getting all the points. So everybody needs all the points so they can get.
Yeah, Miss Pelham, about my 2 quizzes.
Yeah, I know. Yeah, I'll talk with you in a minute. So, everybody got that? Yes?
Yes, ma'am.
Okay. Now, when we're doing quizzes on ProProfs, I give you time. These were supposed to have been done. Quiz 32 and 33 were actually supposed to have been done last week. And then quiz F was supposed to have been Monday, but I told you I gave them all where they were open all day. Okay? But it should have been by like 6 o'clock yesterday. I even sent out the reminder email by 6 p.m. Okay? I said afternoon. Afternoon ends at 6 p.m. 6 p.m. starts evening. So if something's supposed to be done by that afternoon, that would be before 6 p.m.
Yeah, I don't know all those technical terms.
Yeah, that's not technical terms, honey. That's just time.
Nah.
It's not even technical.
No. I'm not that much of a scholar.
Push. Okay, I'm gonna mute you. We need to just make sure we work on this, okay?
Mm-hmm.
On time, being ready, being with the quizzes. All right?
Yes, ma'am.
Okay. So, Marquise and Jazaria, I need to still talk to you about the quizzes that you still got to take. Everybody else can go, and I'll see you tomorrow.
Bye.
Bye. Ding, ding, ding. All right. So, Marquise, you still have quiz 33, I believe it was, that you didn't take.
Yes, ma'am.
Zaria, you missed taking 32 and 33.
Yeah, I had took them, but then my Wi-Fi turned off. And while I was like clicking on it to submit my answers, that's when it turned off.
Yeah, because it didn't show that you'd even logged in at all on my end. So I don't know what happened with that. Because that's why I told you in that one email when I answered you back after Compassion yesterday morning, I was like, it's not showing anything. So